Lesson 8.3, Video 4. We're given a function above that has some changes to it, but all we're being asked to give is the coordinates of the vertex and the y-intercept. Now the coordinates of the vertex is easy because this is a function in vertex form, which is meant to be able to tell us the coordinates of the vertex by looking at it. But we have to be savvy and understand how to interpret it properly. We have a 6 in the parentheses, which means opposite of what you think. It will not go to the right 6, it will go to the left 6. So the new vertex is now at -6, so it went left 6. The y part is as is, so you have a -14, so it shifts down 14. So if you interpret that properly, finding the vertex is not that difficult. Now we have one negative to vertex form, and that is if I give you something in standard form, the y-intercept is found by plugging a 0 in for x, which would take those away, and c is then your y-intercept. But remember, to find that y-intercept, we just plug in zeros. It was easy to calculate, which is good, but again, we still had to find it by plugging in zeros. That same rule applies to this kind of question. We still have to say that x equals 0, but it's just not quite as obvious. So we take the problem, we plug in 0 for x, and we get six squared inside the parentheses. 6 squared is 36. 1/3 of 36 is 12. So we get -2. So the y-intercept is -2. Now this is important because, again, in standard form, whatever the constant was our y-intercept. In vertex form, we actually plug a 0 in, and we're not guaranteed that anything cancels out. So lots of people by accident would say that, oh, -14 is your y-intercept, but that's not true when you have a function in vertex form. You actually have to plug in 0 and calculate, and it is usually different than the constant in the function. And this ends Lesson 8.3, Video 4.